Here's a mathematical induction problem, and these are tricky, but I'll explain my thought process as I solve this. We're told to show that 1 plus 2 plus 2 squared plus 2 cubed, and so on, all the way out to 2 to the power of n minus 1 is always equal to 2 to the n minus 1 for all natural numbers n. And mathematical induction, remember, is a two-step process. And in the first step, we just pick some number for n and show that it works. And we can pick any number we want. And so we usually pick a number that's pretty trivial. So if n equals 2, what does this look like? We're going to show that if n is 2, the left side equals the right side. Well, this series here goes out to 2 to the n minus 1. So if n is equal to 2, we need to go out to 2 to the 1. So the left side is just 1 plus 2 to the 1, right, or just 1 plus 2. And then the right side here is 2 to the n is 2 right there, so it's 2 to the power of 2 minus 1. And is that true? Well, sure. 1 plus 2 is 3, and 2 squared minus 1 is 3, so that works. Now step 2, this is the tricky part. Step 2, we show that if it works for some number k, then it also works for k plus 1. So what does this equation look like if n equals k? Well, let's just put in k right there. 1 plus 2 squared plus 2 cubed, and so on, out to 2 to the power of k minus 1. And then the right side will be 2 to the k minus 1. And we want to show that if that is true, then it also works not for k, but for k plus 1. So let me switch colors here. Let's think about what it looks like if n equals k plus 1. So if we put k plus 1 in for n right here, what does this equation look like? Well, it will be 1 plus 2 squared plus 2 cubed, and so on. And how far out do we go? Well, if we're putting in k plus 1 right there, this will be k plus 1 minus 1. We go all the way out to 2 to the power of k. So this is, we're going to have a 2 to the power of k minus 1 and then a 2 to the power of k. Now this would be the same if we hadn't written this term right here, but it's going to be helpful to show it. So go ahead and write that in. And then over here we're putting in k plus 1, so this is 2 to the k plus 1 minus 1. Now what we're trying to do is show that if this is true, then that is true. And so what we do, we assume that this is true and show that it follows from that this is true. Now look at this. Look at the left side here. See that right there? That is this right here. How about that? So that means I can substitute one for the other. So I'm going to take this and plug it in right there. And that left side becomes this plus this 2 to the k. So the left side becomes 2 to the k minus 1 plus 2 to the k. And on the right side, this is 2 to the k plus 1 minus 1. Now, are those the same? Yeah, look at this. 2 to the k plus 2 to the k. Let me scroll down here. 2 to the k plus 2 to the k is 2 times 2 to the k. And then we still have the minus 1. And 2 times 2 to the k is the same as 2 to the 1 times 2 to the k. And you can see that 2 times 1, or 2 to the 1 times 2 to the k is just 2 to the k plus 1 minus 1, which is the right side. So that works. So what we've shown is that if it's true for n equals k, then it's also true for n equals k plus 1. So it must be true for every natural number n.